Start a new one. All right, next, what do we got? I have a request for problem number 3 on the review, and then number 11. And Mila, was that 11 on the review or the applications part of the homework?
The review.
The review also, okay, so 3 and 11. Let's go take a peek. Review. That would be in the second section. So use the normal distribution, margin of error. Yeah, there's that z times sig over the square root of n. Okay, find the for the confidence level, find the critical value. So a critical value, number 6 also, yes, absolutely. A critical value is a z-score or a t-score, is what a critical value is. So, and that comes from either, oh, I said I was going to show stat key too, and I forgot to do that. I'll show stat key now. You can either use stat key or you can use a spreadsheet calculator. So back in the notes over here, in that flow chart I had made, the z-score, the t-score, or this z-score here, those are all called critical values. So let's label those red. And so the same, let's put a little star, like an asterisk. So that's a critical value, that's a critical value, and this z-score here is a critical value. So we just have to choose the right kind of critical value to find. Show desktop. So this one says to use the normal distribution where you are given the population standard deviation. So that is definitely a z-score. So there's 2 ways I could do that. I could use stat key to do it. So let's do stat key since I haven't used that yet. That would be a theoretical normal distribution. Z-scores, the mean is 0 and the standard deviation is 1, and that's the way the program comes to us. So I don't need to edit the parameters. 0 and 1 is okay. Then you can set a left tail or right tail, it doesn't matter. You just need to know the tail probability. So in this problem here, they said to use a 92% confidence level. So let's just sketch that out quick to make sure we get it right. And this is number 3. So we want a confidence level of 92%. So a quick sketch on that. 92% has to go in the middle. So that's this region here. If I take 1 minus 92% as a decimal, that's going to give me 8%. And that's what we call alpha. So the tails get that alpha split. So alpha over 2. So that 0.08 over 2 means each tail gets 4%. So this tail gets 4%, and this tail gets 4%. So I can either look at the left tail or the right tail to get the right z-score. If this one's positive, this one's negative. For z-scores, 0 is always in the middle, and z-scores are critical values. So I'll do this on the spreadsheet next too. Show desktop, stat key. So the tails, if we add up the tails and the confidence level, we got to get 100%. That is correct. Yep. So I'll do a left tail just for fun, and then I want to set that percentage to, instead of 2.5% that they gave me, I'm going to set it to 4% as a decimal, so 0.04. I think I got that right. And so it says, and I ignore the sign just because the other one will be the same but positive. So I would just call it 1.751. So this would be 1.751. Was that what it was? Yeah. So this would be 1.751. Ah, pen's freaking out. And it won't erase. Oh, come on. Excuse the telephone if you can hear it in the background. 1.751, and this one would be negative 1.751. And when we talk about a critical value, we just give the positive version because they're mirror images. If I wanted to use a spreadsheet for this instead of stat key to find the critical Z, that is that norm inverse, norm.inv, and then I would give it the 4% for the tail, and then z-scores always have a mean of 0 and a standard deviation of 1. So this is the left tail probability. That's the mean of a z-score. And that's the standard deviation of z-scores, which is always 0 and 1. Same for t-scores, but they don't ask for it with a t-score. Just the way it is. So I can double check that on my spreadsheet. And so that would be the norm dot inverse and the 0.04. It's got to be a decimal, 0, 1. And I should just get the same number, but more decimal places, okay? So if I needed more decimal places, I got them. Stack key only gives me the 3 decimal places. It's easier to use, but only 3 decimal places. Okay, that was number 3. What was next? Number 11, and then number 6. All right, jumping down. Is 6 on this page? It is not. Let's do them out of order then, the way they were asked. So 11 is what? Probably confidence interval for proportion. Okay, so we wish to estimate the percent of adult residents in a certain county that are parents. Out of 300 adult residents sampled, 279 had kids, and yours will be slightly different. Based on this, construct a 95% confidence interval for the proportion P of adult residents who are parents in this county. Okie doke. And so there's 2 ways we can do this. We can do it with stack key or the central limit theorem formulas. So back to, actually, let's screenshot it so we can scribble on it. And it wants to know the upper and lower values. So new page. And again, this is number 11 in the practice, or review, I called it, sorry. So important things here. I have a proportion. This number we often would call X, and this is my N, and this is my confidence level. Okay, so my P prime, which is the estimate, the sample proportion, that's that, whatever 279 over 300 is. We'll put this in a spreadsheet in a second. It's supposed to be a 0. And then Q prime will be 1 minus whatever that is. We'll just do that in a spreadsheet. Confidence level is 95. Okay, I think we got everything we need. The formula, by the way, for the margin of error, which is going to help us get the upper and lower bound. So this is the error bound on the proportion. That's where we have to find the right z-score based on the confidence level. And then we need to multiply that by the square root of P prime times Q prime divided by, the sample size N. And then on a spreadsheet, again, to find that, that would be the inverse, norm inverse. Parentheses. And then it wants what? Alpha over 2, 0, 1. Is that z-score. So let's get a spreadsheet, and we can also do this in stack key in a couple of different ways. Spreadsheet, I need a new page, and this is review 11. Why is Zoom flashing at me? What's the matter, Zoom? I don't know why Zoom is flashing at me. No messages. Let's see, are there any new chats? Maybe it's telling me I didn't look at the chats lately. Okay, so this is proportion of adults with children. Adults. And we were given X, adults, 279 had children out of a sample size of N, which was 300. And did I get those numbers right? 279 out of 300. Well, that's a high proportion. I doubt that. but that's okay. Spreadsheet, there you are. Other given information was the confidence level, and that was 95%, usual one. 95, and I'm going to make it a percent. Okay, so from that I have to calculate a bunch of stuff. I need to know alpha over 2, and so usually I just find alpha first, which is, oops, 1 minus the confidence level, and then I cut that in half to get each part for the tail. So alpha over 2. And I have a spreadsheet pre-made for this. Feel free to plug numbers into that. It was linked earlier in this section. Let's see, so take the above number, divide by 2, and then based on that, I can find the z-score. And that's the norm dot inverse. And it wants to know what's alpha over 2, 0, 1. And remember I messed this up earlier, and I'll show you what that means too, that messed up version I gave. I also need to know what is p prime. So that means I have to do the division, 279 divided by the 300. And I should get q prime here, which is always 1 minus that. Okay, so once I have those 3 pieces of information in the sample size, I can get the margin of error. So the error bound on the proportion, or just the margin of error, that's going to be equal to the z-score. Now notice the negative there. So I'm just going to tweak that by putting, oops, I can put either a double negative that or put a negative in here because I want to state at the positive version of it. So I'll deal with that in a second. Square root is SQRT in a spreadsheet, and then I want to know P prime times Q prime divided by N. And I don't like that negative in there, so I'm just going to sneak in between the equal side and the normal and say change the sign by throwing a little negative in front of it. And I accidentally did a slightly different version in my notes. Remember, if any of you signed in the beginning here, I had miswrote these formulas here. So I'm going to type in the way I accidentally put it in because it actually is significant. What I said before was when you do the norm inverse, if you enter your alpha over 2, and then instead of putting a 0 in, you put the population mean, in this case the proportion, and then this what's called the standard error, that was that crazy square root, which I didn't calculate separately here. So if I put the SQRT in here instead, and then what does it need? It needs P prime times Q prime over square root of N, close the root, close the inverse. Oh, that didn't do what I thought it was going to do. I lied. How did I lie? Norm inverse, alpha over 2. Oh, I want norm dot inverse. Shit. Yeah, the dot matters. It gives a different calculation otherwise. Why it gives the same thing? Oh, the dot didn't get kept. Why not? Dot. Put the dot in there, please. What? Why won't you put the dot in there? Do I have to retype you? Weird. It's being difficult. Norm dot inverse. Try one more time, then I'm giving up. Alpha over 2. If I put the sample mean instead of 0 in there, and the standard error, which for proportion is that crazy square root. All right, let's hope it works this time. Times Q prime divided by the N inside the square root. What the hell? Why does it keep taking the dot out? The internet is screwing with me here. It took it out of that one too. Huh. Okay, I'm gonna have to get back to you on that. What the hell is going on there? Okay, let me put a note on my paper over here. Why didn't that work? Why did it screw with me? So norm inverse alternative. What happened? All right, anyway, I have the margin of error. This wanted not the margin of error, but the lower and the upper. So that means I have to add and subtract that. So just a summary of where I am on my notebook. So you should always take paper notes on these in addition to playing with the calculator. This one here. Yep. So I should always have, anytime I do a confidence interval or hypothesis test, a sketch. Let's look something like this. In the middle here goes our P prime, and this one came out to be, what was it, 93%? We'll check that. Yep, 93%. That's our P prime. And then we want to find these numbers on each side such that we have a 95% confidence interval. So that put 2.5% in each tail. We just found for z-scores, z equals 0 is in the middle, and we calculated a z-score of 1.96-ish, which is pretty standard for the 95% confidence level. So z was 1.96 on this side and negative 1.96 on the other side. This square root right here is what we call the standard error for a proportion. And so once I know that standard error, I can use the z-scores to scale it out to get me these values here and here. And we just determined that the distance from the point, the 93%, to get to the edge is what, about 2.8%? Is that what we found for the margin? Yeah, 2.9%, if we round it a little bit. So we just calculated a margin of error bound on the proportion to be about 0.029-ish. So we have to add it to one side and then take it away to get to the other side. So that's what we're going to do next to get the actual interval. So the lower number would be the P prime minus the margin of error, and then the upper would be P prime plus the margin of error. So we believe that the proportion of adults with children in this county is somewhere between 90.1% and 95.9%. So let's put that in the picture, and then we could enter it into the problem. So this one over here was about 0.901, and this one was what, 95, no, I read that wrong. Yeah, oh yeah, 95.9. Come here. There you go. So the upper bound was 0.959-ish. So that's the actual interval they were asking about. So 0.901 to 3 decimal places, 0.959. Ooh, I got it right. And again, StatKey does this too. We could use their simulator to do this, or we could get the z-scores that way. So the way we were doing this 3 weeks ago was a confidence interval for a proportion, and then we would change the sample data to be whatever we have to, what was it, 279, no, 297 over 300. Let's see if I get that right. Out of my way, zoom. Oops, no, that's not right. What was it? 279, I had it right the first time. Edit data. And then it gives me that, yeah, 0.93 there. And then we would just generate. And this one right here, let's see, 279, that means there are about 21 people who didn't, let's let's see, I have a question. How did you get P prime on Excel? So P prime is always the sample proportion. So that's that 279 divided by the 300. So I just asked the spreadsheet to do that for me. So take the 279 divided by the 300. And so then in stat key, and again, notice this is a bit of a skew to it. That's because 93 is such a high percentage. We do two tail, it puts 95 in the middle. So stat key claims the interval is from about 0.900 to 0.957, which is pretty darn close to the one we found. Every time I run stat key, these numbers might be slightly different. So if I reset this and generate another 7,000 samples, do a two tail, double check you have the right confidence level. Oh, I get the same values. So it's close to what the central limit theorem says it should be. And this is just an experimental simulation to try and do that. So again, stat key is way easier, but with stat key, we can't do things like estimate the sample size we need to get a certain margin of error. So stat key has a lot of power, but it also has some limitations to this method. And the kind of both of them together give us more power. All right, let's see, we're about time to finish. I think we got one more question. Number 6, which should be in the previous section, using the t distribution. Okay, so assume that the sample uses, assume that a sample is used to estimate a population mean, mu, find the margin of error that corresponds to a sample size of 9, and with a mean of 28.3 and a standard deviation of 20.5 at a confidence level of 90%. Given that we have so little information to go on here, we don't have enough information to use stat key. We have to use these formulas in a spreadsheet. So margin of error accurate to 1 decimal place. Okay. Screenshot it and let's get busy. And this is number 6. Oops. Come on, Zoom, get out of my way. Ah. Oh, come on. Sorry, my Zoom menus are floating in the screen in front of where I need to write. There, oh, whatever. Okay, so let me see. We're estimating a population mean. So in our tree back here, we're down this branch. And then the question is, were we given the population standard deviation or not? And the answer was we were not. Also, we go down this branch right here for small samples. Oops. What does small mean here? According to chapter 7, small means under 30. Oops, I was supposed to say sample. So there's the two reasons we go down the branch that uses t's. One more page, there we go. So nowhere here does it say we have the population standard deviation. They give us sample information. And so they're giving us n here, the sample size, x bar, and they're giving us s, the sample standard deviation. And then we have the confidence level here. The formula, let's see, for the margin of error, so I was calling that the error bound on the mean, is to find the appropriate t-score, multiply by s, and divide by the square root of the sample size. And to find the t-score, we need to whip out a spreadsheet, and the t-score is, let's see, t dot inverse alpha over 2, that tail probability, and then n minus 1. So if we have 90% for the confidence level, then there's going to be 5% in each tail. So let's plug this into a spreadsheet. So we have x bar. And oh, maybe I'll show, I don't know, has anyone tried those spreadsheets I gave out to reuse? Could try one of those. N equals 9. Confidence level is 90. Let's do that for a change. So show desktop, back to the home page. And then in week 9, I gave a sample spreadsheet for doing confidence intervals and a sample spreadsheet for doing hypothesis tests. And you can kind of just plug in your information and the spreadsheet will calculate stuff. So this is a confidence interval. So this one right here. And then this is a mean. And then once I'm in the mean, I have to decide, is this a mean where I use t-scores or a mean where I use z-scores? And I decided earlier this is one with t-scores. And then I plug in my information. A note on this, I show a picture here from StatKey of this data. If you change the data, that picture is then irrelevant, okay? So I'm gonna make a copy of this so I don't mess up your version. I can see someone just logged into it. And for you to use this, you have to, if you're a Google user, make a copy. If you are an Excel user, then download it as an Excel file if you want to use it. All right, so let me close this one and get to my copy. All right, so mean, what was I given? Mine said 28.3, so I'm going to edit this right here, 28.3. And then my sample size is a 9. My sample standard deviation was given to be 20.5. And then my confidence level was given to be 90%, which this one already has, so that's good. Again, this picture here is not relevant. I'm going to delete it. Okay, so I could, actually I could use StatKey to do this if I use the let's see, which one is this? A t-dist, yeah. Okay, so this tells me the critical value, this tells me the margin of error. So that's what I want right there. So this says, hey, margin of error is 12.71-ish. And then it also calculates the error bounds for you. And then further down, if we were given the data, we could plug in our data and then make these calculations. But we weren't given the data, we were just given the summary statistics. Can't find that spreadsheet. Okay, so you got to go to the home page. And then on the home page, you got to be in week 9. Once you're in week 9, it's called Model Confidence Intervals with Spreadsheets. Once you get to that page, then you either pick that you're working with a mean or a proportion. In this case, we're doing a mean, and that's this one here. Cool. So I like this spreadsheet in that it's, it groups stuff together and it makes the calculations for you, but I don't know, it kind of takes the fun out of it. But some people don't think this is fun, so hey, you get it done quicker. Congratulations. So enjoy this, but again, you got to make sure you pick the right region. Do you have summary statistics? Do you have data? Are you doing a T interval or a D interval? There's even a spot that'll find the sample size for you where you plug in the given information and it'll whip out the other stuff you need. Okay, I think that, let me double check I addressed the questions that were asked here. And just in case, I'm going to stop this recording while I read.